Okay, so in question 6, we are given some two datas in the form of tuple, of whom we have to find some distance, which are Euclidean distance, Manhattan distance, and so on. So we will start it to solve it using pen and paper. So the first thing they have asked, let's just first write the data sets. So currently we have a data set of an body A and another body which is B. So the data set is 22, 1, 42 and 10 of A, and another one is 20, 0, 36 and 8. So what we will first do is that we will find out a difference, right? So difference. We are doing this so that in future when we apply the formulas for different distance methods, it will be easy for us to do some calculations, right? So the difference, basically we have to difference the each and every value of A and B, right? So let's just say this is x1, x2, x3, x4, and this is y1, y2, y3 and y4. So we will get the difference, which is x1 minus y1, x2 minus y2, x3 minus y3, x4 minus y4, right? So if we subtract it, we will get a value 2162. This is important value, so we'll use it in future, right? So the first question they have asked is to find the Euclidean distance. Euclidean distance. So the formula for Euclidean distance is as follows: d2, the root of summation of I is equal to from 0 up till n, right? Or let's just say from 1 till n, xi minus yi whole square, right? So if we put this formula inside our data set, it will be d2. So we'll use differences of which we have found out earlier, right? So x1 minus y1, it is basically the distance which we got it here, right? So the d2 is equal to the root of 2 square plus 1 square plus 6 square plus 2 square again, right? Eventually it will be root of 45, which is somewhat 6.708 approx, right? So this is how you can find the Euclidean distance for our data set. Another thing which the question wants us to solve is to find out the Manhattan distance. Manhattan distance. Right. So to find out the Manhattan distance, it is a very simple formula. It is the maximum value of xi minus yi inside the absolute value, right? So you will find out the maximum value which you get after the subtraction of these things, right? So if I say, let's just d1 is equal to max. So d1 is equal to okay, so the next thing which they want us to find is the Manhattan distance. The formula for Manhattan distance is basically the summation of absolute values of xi minus yi where I ranges from I till n, right? So if you put these values inside the data set, so it will be the sum of all the absolute values which we will get, right? So it is basically 6 plus 10, which is 11, in modulus, which is 11. So this is the Manhattan value of the question, right? The next thing which they want us to find is the Minkowski distance for h is equal to 3, right? So the general formula for Minkowski distance is the summation of ai minus pi to the power p 1 divided by p, right? Inside this, the p value is the h is equal to 3 and a and b are the x and y, right? So if we plug in these values, p is equal to 3 and xi is the difference. So it will be d3 equals to the summation of all these values, which is 2 to the power 3 plus 1 to the power 3 plus 6 to the power 3 plus 2 to the power 3 whole to the power 1 by 3. If we solve it further down, it will be 8 plus 1 plus 2 and 6 plus 8 plus 1 by 3, right? Okay. If we summation it, it will be 233 to the power 1 by 3. Now you can use the calculator, but the answer is already 6.17 approx, right? So this is the Minkowski's distance for this question, right? The next thing they want us to solve or to find is the supremum distance, which is nothing else but a Chebyshev distance. Supremum distance, right? So the formula, the general formula for is the maximum value you get for this thing, right? So basically the maximum difference you got in your data set, right? So here currently we have a few of it, which is 2, we got 1, we got 6, and we got 2 again. So in here we can clearly see that the sixth value is the maximum, right? So the supremum distance will be 6. So these were the things which this question asked us to solve, and that's all for this question. Thank you.